Good morning. In this video, we'll review the Chapter 2 material. So this is day 2 of the Chapter 2 review. First thing we're going to look at is all the vocab terms, and then we'll get into some examples. So let's go ahead and get that going. So first page of your notes will look like this. So if you're looking at these top two four boxes, okay, they both have to do with just the word probability. So if I can move that up. So both of these here are probabilities. Or they both have to do with probability. So the first one is more just what the formula is. Okay, the probability box here, okay, this is what our probability answers are allowed to be. So smallest answer of 0, biggest answer of 1 or 100%. Okay, so that's that one. Okay, then if we scroll back down, okay, if we look at the box on the left here, all right, this is going to be between two different things. Okay, this one right here is what you do for independent probability. You multiply the probability of A times the probability of B. Okay, and then this one's called dependent probability. Okay, where the only main difference is this part right here, which maybe didn't come up in our notes. Okay, this right here means probability of B given that A happened. Okay, so a dependent probability, meaning that second thing is depending on what happened first. Okay, next, looking at these ones here, we're looking at some opposites. They're called complements. Both of these are complements. Okay, that A with a C by it means not A. So if we want to figure out the probability that something does not happen, we just take 100% minus the probability that it does happen. All right, and then the bottom two have to do with adding. So if two things are mutually exclusive, then you don't need to subtract anything when you are doing OR problems, okay? Because it means that both things are not possible to occur at the same time, okay? Where if something is non-mutually exclusive, we're looking at subtracting that overlap, okay? So this right here, okay, is like the probability of A and B. All right, so that's some of the vocab that'll come into play on the next ones. Let's try some examples. So just some basic ones. Let's not forget how to do the easy ones. So the probability, what is the probability of drawing a 10 from a standard deck? Standard deck means 52 cards. So the probability that we draw a 10 is just how many 10s there are in the deck. That would be 4. 52 total cards. So we have a 1 in 13 chance of getting a 10 on our first draw. So from there, we can leave it as 1 over 13, or we could call this 0.0769 or 7.69%. So answers can always be fractions or decimals or percents. Okay. Second one, what is the probability of drawing a face card? So a face card is going to be either a jack or a queen or a king. Okay, so there's going to be 4 of each of those. There's a total of 12 face cards out of 52. So with that one, we could reduce that. We could divide them both by 4. We can get 3 over 13, so that would be an answer, a reduced fraction, or 23.08 or 0.2308. Okay, so we can answer as a percentage or a reduced fraction or a decimal. And we always go to that 4th decimal place. Okay, what is the probability of drawing a spade? Well, a spade, okay, that's a suit. There's 13 spades in the deck out of 52, so there's a 1 in 4 chance of this happening, which is 0.25, which is 25%. And the probability of drawing a black card, so that's half the deck. Okay, half the cards are red, half the cards are black, so there's a 26 out of 52 chance, which is 1 over 2, which is 0.5, which is 50%. Okay, there's a 50-50 shot drawing black or red. Okay, some more basic ones. Okay, in a jar of 3 red, 4 orange, and 5 purple marbles, what is the probability of not drawing a red marble. So we want the probability that our marble is not red. So one way we do that is with the squiggle. Okay. Well, what we would do, okay, is we would take the ones that aren't red and add them up. There's a total of 9 that are not red. Okay, and there's a total of 12 marbles in the problem or in the bag. Okay, 3 plus 4 plus 5. So this is 9 out of 12. So this is 0.75 or 75%. Okay, if you want to use the reduced fraction, you would have to use 3 over 4. Okay. From that same jar, okay, we want the probability that we get red, orange, or purple. You could do this like an adding problem like we'll review in just a few moments, but we don't really need to. That's all the colors. Okay, there's only red, orange, and purple. So there's a 100% chance of this happening. Okay, those are the only 3 colors in the bag or in the jar. Okay, and then this one is related to complements, the opposites. If there's an 80% chance you get a B on the upcoming test, what is the probability you don't get a B? So the probability that we don't get a B, so I'll do B with a C this time for the opposite of B. It's just 100% minus the probability that you do get a B. All right, which is 100% minus 80%. So there's a 20% chance that we get something else, either an A or a C or a D or an F. Okay, so that's just the basic ones. Okay, we'll get into some that maybe can be a little bit trickier. So the ones with the grids, just remember that there's 36 total ways that you can roll 2 dice and add them together. All right, so they want first, what is the probability that we get a sum of 10? Okay, well there's only 3 10s in the grid, so this is just 3 out of 36, which is 1 out of 12, which is 0.0833. 0.0833. All right, so 8.33%. Okay, if they want a 3 or an 8, just find all the 3s and all the 8s. Okay, that should be a total of 7. There's 5 ways to roll an 8, and there's 2 ways to roll a 3. So if we want a 3 or an 8, you can't get a 3 and an 8 at the same time, so nothing's getting counted twice. This is just 7 out of 36. And that comes out to 0.1944 or 19.44%. Okay, but then there's those ones that have combinations in them, so we'll get into that next. So Tisha is in the French club. There are 9 students in the club, 7 are girls. Okay, that's important. All right, the French teacher will choose a group of 3. Okay, to guide students from visiting students from France. What is the probability the group has 2 girls and 1 boy? So this problem takes a couple of combination steps. The first thing is we got to figure out how many groups have 2 girls and 1 boy. That's going to be step 1. Okay, how many groups have that? Okay, so that is just the number of girls are 7, and we need to choose 2 of them. And that means that there must be 2 boys. Okay, there's 2 boys, and I want to choose 1. Okay, if you do that, you get 21 times 2, so 42. There's 42 ways that can happen. Okay, then we need just the number of 3-person groups. Okay, if we do not care what gender they are. So then there's just 9 people, and we want to choose 3 of them. That comes out to 84. All right, and that's the top and bottom of my fraction. So the probability that we get 2 girls and 1 boy. All right, that's just 42 out of 84. This time it just happened to work out nice that that's 1/2 or 50%. So half the groups would have 2 girls and 1 boy. Okay. All right, moving on. So the and versus or. So this will be the last page of your note packet. All right, right here. So the and versus or. All right, looking at that. So if we take a look at that then, what is the probability that one random card drawn from a 52 card deck is an 8 or a club? An 8 or a club. So what we have to look at, okay, when it's an or problem, is we have to look at, for or, we have to look at mutually exclusive or non-mutually exclusive. So can they both happen at the same time? Okay, for and problems, we have to look at independent versus dependent. Okay, does the first one impact the second one? All right, so for this one here, all right, so an 8 or a club, if you're looking at that, the question is, can there be both? Okay, could you be both? The answer to that is yes. Okay, there's a card in the deck that is an 8 and a club. So in that situation, what we need to do is we need to look at the probability that it's an 8 plus the probability that it's a club minus the probability that it's an 8 and a club. Okay. And that's what we'll do. Excuse me. So the probability that it's an 8, that's 4 out of 52. Okay. So since this was yes, that means it's non-mutually exclusive. I meant to write that. Okay. And non-mutually exclusive means we have a subtracting step. All right, so then there's 13 clubs out of 52, but there's one card that is both an 8 and a club. It's called the 8 of clubs. All right, so what we do is we add across the top. We have 17 minus 1, so 16. We leave 52 the same on the bottom. So 16 out of 52 will reduce to 4 out of 13, which is 0.3077, which is 30.77%. All right, so that one is an example of a non-mutually exclusive problem. All right, next, let's keep going. So we have, what is the probability when you draw 2 cards with replacement? Okay, so anytime it starts talking about replacement, okay, now you're looking at independent or dependent. So and this is an and problem. So the first one is a spade and the second one is a face card. So we want the probability the first one is a spade, okay, and then the second one is a face card. Okay, so this is a multiplying problem. If you're putting things back into the deck or into the jar or whatever we're looking at, that's called an independent probability, which means the first thing does not impact the second thing. So we can treat this as 2 separate events and then just multiply them together. So the first one is just the probability that we get a spade. Okay, well that's just the number of spades out of 52, so that's 13 out of 52. The second one is just the number of face cards. Okay, well if I put the card back, there's 52 cards in the deck again. And then there still should be all 12 face cards then, since even if the spade I took out had a face on it, I put it back anyways. Okay, you can reduce these fractions first if that's helpful. So 13 out of 52, that's just 1/4. 12 out of 52, divide them both by 4, that's just 3 out of 13. And then you can multiply top times top, 1 times 3, bottom times bottom, 4 times 13. So that's the reduced fraction right there. Or if you don't want to play with the fractions, you can just punch it into your calculator and get that decimal, which comes out to 5.77%. Okay. Suppose you're dealt 2 cards without replacement. All right, so this next one, okay, it says without replacement. Okay, now this is different. This is called dependent. So now it's still going to be a multiplying problem, but we're not putting the first card back. So what that means is the second fraction, there's only a certain amount out of 51 because we've taken one of the 52 cards out. Okay, we want to put them both to be diamonds. So we want the first one to be a diamond, and we want the second one to be a diamond. So that's what they're asking us to do. So if that's the case, all right, if we want them both to be diamonds, well, the probability that the first one is a diamond is just 13 out of 52. That's how many diamonds there are in the deck. But once we take that diamond out, there's only 51 cards left. So that second one has to go down to 51. Also, the top has to stay it has to go down as well because there was only 13 diamonds, but I took one of them out. So there's only 12 left in the deck. Okay, so same idea. You can reduce these first. This is just 1 out of 4. You can actually reduce 12 and 51. They do have something in common. That's 4 over 17. Okay, if you divide them both by 3. And then you could even cross out those 4s that are diagonal. So what this ends up being is 1 out of 17. Okay, which is really close to the last answer, but 0.0588 or 5.88%. So dependent probabilities, we're looking at changing the second fraction. And if there was a third fraction, that one would have to change too. Okay. These ones where a basketball player makes 85% of their free throws, they're just going to say, what's the probability we make the next 3 or the next 2 or the next 5 or whatever. Okay, so if we make an 85% rate of our free throws, we want to make the next 3 free throws that we take. So the probability that we make the next 3, okay, it's just 85% 3 times in a row, or 0.85 times 0.85 times 0.85. That's really all this problem is asking us to do. Okay, and that comes out to 0.6141. Or 61.41%. Okay. All right, last one for the video. Let's see. It says a bag contains 2 blues, 3 oranges, and 1 green M&M. What is the probability you draw 2 green M&Ms without putting any M&Ms back? So you can see that there should be a bit of a problem with this. Okay, we want the first one to be green and the second one to be green. Okay, but we don't have that many greens. So the first one, there's 6 total M&Ms. The first one being green, that's a 1 out of 6 chance. But if this one says, like it does, no replacement, that means I don't have any, well, first off, I only have 5 M&Ms left, but 0 of them are green. Okay, if it was a with replacement problem, we could do this. But if we're not putting the M&M back first, well, this is just not going to happen. This is anything times 0 is just going to be 0. This can't happen. There's not 2 green M&Ms, so I can't get 2 green M&Ms back to back unless I'm replacing. All right, so hopefully that helps a little bit. You can go and work on the next few pages of your packet. All right, and then the test is coming up soon.